In this second part of Module 2, we will explore chemical sedimentary rocks and how they form and are classified. We will also explore how sediments are ultimately turned into rock. The next type of sedimentary rock we will talk about are chemical sedimentary rocks. They are very different from detrital rocks. Chemical sedimentary rocks form from precipitated material that was once in solution. Precipitation of material occurs by inorganic processes such as evaporation and organic processes from water-dwelling organisms that form biochemical sedimentary rocks. Limestone is the most abundant chemical sedimentary rock. Limestone is mainly composed of the mineral calcite and can form from inorganic and biochemical origins. Limestone is so abundant and forms in several ways, so there are many different ways to classify it. Biochemical limestone originates from the shells of marine organisms, for example. Large quantities of marine limestone are formed from corals. Corals secrete a calcium carbonate skeleton and create reefs. Australia's Great Barrier Reef is the largest coral reef on Earth today, but there have been many in Earth's history that rival the Great Barrier Reef. Coquina is composed of cemented fragments of shell material, and chalk is composed of the tests of microscopic marine organisms. In the lower left photo, you can see the Great Barrier Reef in Australia. The upper right photo is a fossilized Permian age coral reef found in West Texas and southeastern New Mexico. The reef forms the Guadalupe Mountains. Coquina forms on shell beaches, like this beach on Sanibel Island in Florida. You can see this rock is a loosely cemented mass of shell material. In this image, we can see what it takes to make chalk limestone deposits and the end result. The upper center photo is a photo of a massive white chalk cliff. Chalks are biochemical limestones made up of the hard parts of microscopic organisms called tests. The lower right photo is a satellite image of a plankton bloom off of a coastline. These blooms are generally made up of algae called coccolithophores that produce calcium carbonate plates to surround and protect their bodies within. When the algae die off, the plates come apart and settle down to the sea floor, where over time they build up chalk deposits. In the photo on the lower left, you can see a photo from a scanning electron microscope of a group of coccolithophores with their plates intact. For scale, you are looking at these algae through the eye of a needle. Limestone can also form from inorganic processes, though this is not as common as organic limestones. Inorganic limestone forms when chemical changes increase the calcium carbonate content of the water until it precipitates out. Travertine is a type of limestone found in caves. It is precipitated when the water in the cave loses carbon dioxide. Cave formations such as stalagmites and stalactites are formed in this way. Oolitic limestone is composed of small spherical grains called ooids. Ooids form as tiny seeds that roll in shallow marine water supersaturated with calcium carbonate. In the upper photo, you can see modern ooids formed today in places like the Bahamas. Notice the dime for scale. The lower picture is an oolitic limestone. Ooids are the raw material for oolitic limestones. Limestone is not the only chemical sedimentary rock. Dolostone is similar to limestone but contains magnesium. The origin of dolostone is unclear because there is currently no place on Earth today where large quantities are forming as they did in the past. Significant quantities of dolostone were likely created when magnesium rich waters circulated through limestone. Chert, another common sedimentary rock, also forms in marine conditions as beds or nodules. Chert is composed of microcrystalline quartz. It forms when dissolved silica precipitates. Flint, jasper, and agate are all varieties of chert. This image shows several varieties of chert. Some, such as agate and jasper, are used in jewelry. Some are used for utilitarian purposes, such as flint for starting fires, and other varieties used to make arrowheads and spear points. Chert is very hard, and because it is microcrystalline, it produces a very sharp edge. Petrified wood that you see in the lower right corner is fossilized wood that has had its pore spaces filled in with silica or chert. Evaporites are another type of chemical sedimentary rock that form when restricted seaways become oversaturated and salt deposition begins. Rock salt and rock gypsum are two common evaporites. Occasionally, evaporites form on continental salt flats when dissolved materials are precipitated as a white crust on the ground. The Bonneville Salt Flats are a world-renowned speed testing site. Bonneville is an extensive evaporite deposit that in some areas is nearly 2 meters thick. It formed when a large lake dried up at the end of the last ice age. Organic sedimentary rocks form from the carbon-rich remains of organisms. Coal is a common organic sedimentary rock in which plant structures like leaves, bark, and wood are occasionally identifiable. Coal tells us that at one point in time there was a swampy or marshy environment in the location where the coal is found. This illustration shows the stages of coal formation. At time 1, plant remains accumulate in a swamp environment. At time 2, the formation of peat occurs as the material is compressed by overlying weight. Over time, the compression starts to squeeze the water out of the peat and concentrate the carbon of the plant material. The more compressed the coal becomes, the lower its water content goes and the higher its carbon content rises. The lowest grade of coal is lignite, which has high water and low carbon. Industrial grade coal is bituminous coal, which has a lower water content and higher carbon content. If coal becomes metamorphosed, it is called anthracite coal. It's very low in water, very high in carbon, and relatively rare. So, how are all of these sediments that we've talked about turned into rock? Many changes occur to sediment after it is deposited. All of these changes are referred to as diagenesis. Diagenesis encompasses the chemical, physical, and biological changes that take place after sediments are deposited and buried. It occurs within the upper few kilometers of Earth's crust. One example is the recrystallization of more stable minerals from less stable ones. For example, aragonite to calcite. After sediment is deposited, lithification, where unconsolidated sediments are transformed into sedimentary rocks, occurs through two mechanisms. Compaction, which involves the burial of sediments where the weight of the overlying material compresses the deeper sediments. and cementation, which involves the crystallization of minerals among the individual sediment grains. This is the end of Sedimentary Rocks Part 2. In Part 3, we will look at environments of deposition.